Hi, my name is Jesse Turner. I'm the Director of Research and Development for Green Mill Supercritical, and we're here showing off our system and specifically showing off our innovative new real-time winterization system that does away with ethanol-based winterization. So real-time winterization is a game changer for the industry, and it will be the new standard because it completely removes the need for ethanol-based winterization when you're running CO2 extractions. So basically it allows the processor that's running CO2 to extract their biomass, and the end result doesn't need to go through winterization. No need for rotovaps, cryo freezers. Any of that process is completely eliminated during the standard extraction process. So real-time winterization provides significant advantages with OPEX and CAPEX considerations because of the efficiencies that it brings to the extraction process. So not only are you able to collect more and retain more of the cannabinoids through the extraction process, but your lab space is reduced and the amount of equipment that you have to produce or to purchase is reduced as well. So Project Extract is Green Mill's technical blog on anything related to extraction, and we have that divided up into two distinct categories. One is the sandbox, which is just more general knowledge on the topic of extraction. We have articles that we write, trying to help customers to understand CO2 extraction, from the basics to more advanced. And then we have our knowledge base, which is where we publish our white papers that we produce. And those are very data-based, scientific papers that we put together that really, we're doing our best to push forward the idea that when you bring something innovative to market, you need to be able to back it with data, and you need to be able to, show your work on what you're doing. And so that's that section of Project Extracts. And so we kind of use both of them combined as our spearhead, to explain what we're doing. So we've collected some really good data on two distinct compounds. One is the cannabinoid retention using our real-time winterization system. The other is, very full profile terpene extractions that we're able to do. And so basically the cannabinoid extraction, we tested all throughout the process to determine, compared to standard ethanol-based winterization, what our cannabinoid losses look like through the process. Typically, that process on the ethanol-based side is around 95% recovery rate, which means that about 5% of your cannabinoids are going to be lost in transfer loss or in the wax cake. And through our real-time winterization process, we were seeing a recovery rate of 99.93% average. So those are cannabinoids that would typically be lost that are, now being put into finished product and, helping that bottom line for processors. The second is our terpene testing that we did. And one of the things with CO2 is there's kind of two schools of thought on how you do terpene extractions. One is low density supercritical CO2, and the other is liquid CO2. And one of the issues that happened with low density CO2 extractions is they weren't always sufficient to pull out some of the heavier molecular weight terpene compounds like your sesquiterpenes. And so what the real-time winterization system allowed us to do and what the data showed is we were able to pull out those heavier molecular weight terpene compounds to provide a true profile while de-waxing. Because that was the issue before, is you would get waxes if you raised your density up. So it was kind of, you always had to be in this, this small area to do terpene extractions. And now with this, we're able to increase the density, de-wax, and get a very, very clean profile that's indicative of what's coming out of the biomass. So anyone that's interested in, learning more about Green Mill, whether it's our real-time winterization system, our SFE extraction systems, or just in general with, extraction knowledge, feel free to look us up on our website at projectextract.com or greenmillsfe.com, or even reach out to myself on LinkedIn.